6, Applications of Systems of Linear Equations, Part 2. So this continues on what we were doing yesterday with Part 1, Lesson 5. The hardest part to these is not the solving of the system, it's trying to get to the system. And so the questions that we were working on yesterday, the strategies that we came up with, the big thing is you have to identify your variables first. You have to say X is going to be the cost of a pen, Y is going to be the cost of a pencil. Or X is the amount of money I'd put in that 12% fund, Y is the amount of money I'd put in that 10.5% fund. Something that identifies what your unknowns are so that when you go to start writing your equations, you're not getting mixed up all the time. The questions that we look at today look at mixture applications and then distance, speed, and time problems. So mixture applications, this actually leads us into some chemistry stuff. Not the first question, but the second question. So if I look at the first question, cashew nuts cost $22 a kilogram, and they're mixed with Brazil nuts that cost $16 a kilogram. Together, the mixture weighs 50 kilograms, and the price is $18 a kilogram. How many kilograms of each type were used in the mixture? And this is something that someone somewhere has crunched the numbers to determine. Trail mix does not just happen by accident. They take peanuts and the raisins and the M&Ms and all of the stuff that you find in trail mix were each in individual amounts that they mix together. So in order to come up with that price of the trail mix, you have to take into consideration the price of all of the ingredients that went into it and what the proportions are of them. It's not just half and half. Okay? Which is why you always end up with the stuff in trail mix that you don't like, because there's more of it than anything else. So if I look back to this question, I have cashew nuts and I have Brazil nuts. So give me a variable I could use in this case. C and B. And what would C stand for? Okay, it's the amount of the cashews. So amount of cashews in kilograms. And then B is the amount of Brazil nuts in kilograms as well. So what do I know about the amount of cashew nuts and the amount of Brazil nuts? There's 50 kilograms altogether, so how could I use that knowledge to write an equation? C plus B equals 50. Okay? What else do I know? Okay, how much it sells per kilogram. So if C is the number of kilograms for cashews, what does 22C represent?
How much money per kilogram?
Yeah, so if I have 3 kilograms, it would be 3 times 22. And then what would it be for the Brazil nuts? And what would that equal? 18 times what, though? Why 50?
Because that's how many kilograms I have.
That's how many kilograms I have. Good. So what's 18 times 50? It's not that big of a number. 900. So I have 22C plus 16B equals 900. Okay, so now I need to solve these two systems. So do I want to solve by substitution or do I want to solve by elimination? Or does it really matter? Could I use either way? Yeah, because I have coefficients of 1. So if I have a coefficient of 1, I could do substitution. If I did substitution, I could put the B to the other side, and I would get 50 minus B in that first equation, which I can now substitute in for C in the second equation. So 22, and instead of C now I have 50 minus B plus 16B equals 900. So what is 22 times 50?
1100.
Minus 22B plus 16B equals 900. Now what would I do?
Add the B's together.
Add the B's together, and how many B's do I have?
6.
Positive or negative? Negative 6 B's. And what do I do with the 1100? Subtract. So then I would get negative 6B equals what?
Negative 200.
Negative 200. And then B would equal, what is negative 200 divided by 6?
33.3 repeating.
Okay, so 33. And how do I write 0.3 repeating as a fraction?
Go down.
1/3. So I have 33 1/3 kilograms of Brazil nuts in my mixture. So then my cashews would be 50 minus the 33 1/3, which is how much?
16 2/3.
16 2/3. So I have 16 2/3 kilograms of cashews and 33 1/3 kilograms of Brazil nuts. Or if you're in Brazil, they're just called nuts. And then I could go through and I could double check this. I already know that if I add these two amounts together, I do get the 50 kilograms. But what I could do is I could figure out, well, if I go 22 times 16 2/3 and 16 times 33 1/3, do I get, not $1,100, $900, which is the 18 times 50? And the answer is yes, you do. Okay. So that's one example of a mixture type question. If we look at the next mixture type question, we have Earl the chemist. He has to make 180 milliliters of a 60% hydrochloric acid solution. He has 1 liter bottle of a 45% solution and a 1 liter bottle of a 70% solution. How many milliliters from each solution would he need to make the 60% solution? Because I can't just pour them together. I can't just go half and half. The 45 and the 70 is not going to give me 60 if I go half and half. But if I can figure out their proportions, I then can make my 60% solution. Okay? So again, start off by identifying my unknowns. What are my two variables? Or what are my two things that I'm using? So what am I trying to do?
And how many liters of each hydrochloric solution?
Okay, so my unknowns are the amount of each type of solution. So I could let X be the amount in milliliters of the 45% solution. And then Y could be the amount in milliliters of the 70% solution. Together, how much of the solution do I need to make? I need to make a 60% solution, but I need it to be 180 milliliters. So if I take the amount from X and the amount from Y, I will get 180 milliliters. Okay? Now, if I have the amount of X, the percentage of that amount in terms of concentration is going to be the 45% X. And then the 70% Y, what does that have to equal? The 60% of 180. What is 60% of 180? 108. And again, I could use my method of substitution. I could rewrite this equation. So if I rewrote this equation and I isolated X, I would get 180 minus Y. And I could substitute that into this part here. 0.45 times 180 minus Y plus 0.7 Y. And now I have an equation that has one variable, which is better to solve. So when I remove the brackets, what do I get? 81. So I get 81 minus 0.45y plus 0.7y equals 108. If I combine the y's, what do I get? 0.25. And what do I do with the 81? Subtract it. So what's 108 subtracting the 81?
27.
And then I divide by 0.25, and what does y equal? And this is 108 milliliters. So I need 108 milliliters of the 70% solution. And then the X is 180 minus 108, which is how much? And then my final step will be to write my sentence answers. So I need 72 mils of the 45% solution and 108 mils of the 70% solution. So in these mixture type questions, one thing to notice is the second equation is just taking the first equation and putting in those multiplying factors. In this case, it was the percentage concentration of each solution. In the previous example, it was the amount per kilogram of each component. Okay, so it's a bit different than some of the equations we were writing yesterday. Distance, speed, and time problems. Or I like to rename them STDs because it's more memorable. The triangle that you guys learned in physics with D at the top, that allows you to be able to put together your formula. If I cover up the D, I multiply S and T. If I'm trying to find time, I cover the T up and I've got distance divided by speed. For these questions, charts probably are your best tool to help you organize the information. So, a student is driving 1,245 kilometers from Edmonton to Vancouver and does it in 16.5 hours. This includes a 1-hour stop in Golden and a 30-minute stop in Kamloops. averaged 100 kilometers per hour on the divided highways and 75 kilometers per hour on the non-divided mountainous roads. Because in BC, if you see a sign that says this, you need to slow down because the curve does that. It's not like in Alberta where it's kind of like a curve. They recommend that maybe you slow down to 80, but you can probably keep the speed. No, if it's like this and it tells you to slow down, you want to slow down because it means you're going around the outside edge of a mountain. And if you don't slow down, you go off the edge of the mountain.
It's just a suggestion.
It's not really a suggestion in BC. And they have no ditches. It's like road and cliff. Oh,
Road,
yeah.
cliff, or road, mountain.
It's fun. Okay. So the question is, how much time did she spend on the divided highways? So if I put this together, this is a distance, speed, and time question. So if I make my chart is going to have distance, speed, and time. And there are two different aspects to my driving. There's the part that I drove on the divided highway and the part that I drove on the non-divided highway. Now, what do I know about the time I spent driving on the divided highway? Do I know anything?
Yeah, it goes 75.
On which part? So the speed on the non-divided is 75. Is 100. Do I know how much time I spent on the divided highway? Do I know how much I spent on the non-divided? Those become my unknowns. X and Y. So again, if I go back to that formula, if I'm trying to find distance and I cover it up, what do? Multiply speed and time. So if I multiply speed and time in my first row, I would get 100x, and in the second row, I get 75y. Okay, what else do I know about this question?
She was driving for
16 and a half hours. So her total time is 16 and a half. So the x time and the y time gives me 16 and a half. Is it 16 and a half?
She actually stopped. She only drove for 15 hours. She stopped for an hour in Golden and half an hour.
Right. So the total time was 16 and a half. Take off the 1 hour stop in Golden. The half hour in Kamloops gives me 15 hours for driving time. And what else do I know?
She had to go 12.
100x plus 75 watt equals 1245.
Yeah, I know the total distance, and the total distance would be the sum of the two individual distances. So 100x plus 75y equals 1245. Okay. Seeing how we've done two questions with substitution, let's look at this one as elimination. If I wanted to do an elimination for this one, what can I multiply that equation by? 75. Why would you pick 75? Well, you could pick 75 or you could pick 100. If I pick 75, it's 75x plus 75y, and what is 15 times 75?
1,000.
Okay. So if I had chosen 100, I would I would end up with negatives if I was subtracting them and putting the second line, because I'd have 100y, and then this number here would be 1500. Or I could reverse them and then eliminate the need for negatives. So I'd have to subtract these two equations, 100 minus 75. 25x. The y's would cancel out. And what is 1245 minus 1125? 120?
Yep.
Okay, and if I divide 120 by 25, I get,
4.8.
and 4.8 is the time spent driving on the divided out highway. So she spent 4.8 hours. And I don't actually need to do the non-divided. I just needed to answer the divided part. So I wouldn't even need to go back and find the rest of it. Although I could if I wanted to. Okay, how's that so far? The small cruise boat takes 3 hours to travel 36 kilometers down a river with the current. On the return, it took 4 hours against the current. Find the speed of the current and the speed of the small cruise boat in still water. So we are going to set up our distance, speed, and time chart again. So what are the two parts to my trick?
With the current and against the current.
So upstream and downstream. Okay? So with the current, that was downstream. And against the current would be upstream. What do I know about these trips?
Distance is 36.
The distance was 36. Okay, I'm going to leave that for now. What else do I know?
Take 3 hours to travel downstream and 4 hours to travel upstream.
Okay. What's my speed?
Don't know.
I don't know. But what do I know is happening? When I'm going down the stream, what do I have to take into consideration? What's happening? Why am I going faster?
Because you're going with the current. The current is pushing you.
So the current is pushing me. So I have two things happening. I have the boat and I have the current. Those are my unknowns. So I could let x be the speed of the boat in kilometers per hour, and then y would be the speed of the current. In kilometers per hour. So then as I'm going down the river, the boat and the current are working together. When I'm coming back up, they're working against each other. So that current is actually taking away from the speed of the boat. And then when I go to complete this, I'm still going to use the 36 that you told me about, Raylan, but right in here, if I go back to my formula, this is speed times time. But together, that allows me to make my equations. Downstream, I get a distance of 36. And upstream, I have a distance of 36. So then I've got 3x plus 3y equals 36. 4x minus 4y equals 36. So if I chose to solve these by elimination, what do I want to find? The speed of the boat or the speed of the current? Pick one. Speed of the boat. Speed of the boat. There we go. Let's find the speed of the boat. So what would be my common coefficient that I would need? 12. So if I need 12, what do I multiply this one by? 4. Okay. So I get 4x, or not 4x, multiplied by 4. And I get 12x plus 12y equals, what is 136 times 4?
136 times
Or sorry, what's 36 times 4?
144.
Yep. What happens when you double 36? What do you get?
72.
And when you double 72 again?
104.
So multiplying by 4 is like doubling twice. Okay, so if I multiply the next equation by 3, I get 12x minus 12y equals 36 times 3 this time. 108. What operation would I use to eliminate my y's? I would add them because my y's are opposite sides. So how many x's would I get? And 144 plus 108?
252.
52. 8 and 4 would be 12. 144 plus 108. Okay. And what's 252 divided by 24?
10
If I go back to the beginning, 10.5 was the speed of the boat in kilometers per hour, so I have my units. So then my y value, if I plug that into one of those two equations and solve it, I would get 3 times 10.5 plus 3 times y equals 36. What's 3 times 10.5? 31.5 plus 3y equals 36. Subtract 31.5 from each side, and I get 4.5. Divide by 3, and I get 1.5. So the boat has a speed of 10.5 kilometers per hour. The current is 1.5 kilometers per hour. If I add those two together, what do I get? 12. And what's 12 times 3?
36.
36. That's my distance. If I subtract them, what's the difference between 10.5 and 1.5?
9.
9. And over 4 hours?
36.
36. I still get the same distance. So you're going to work on questions 1, 3, 5, and 8 and 9.